Hi, my name's Andy Banta. I work on iSCSI development. I'm a member of the iSCSI development team at VMware. John Hall isn't here today. You can pretend he's here if you're weird. Just want to mention that, as I mentioned, for R&D, we research stuff we don't always develop. We develop stuff we don't always turn into products. If I mention anything that never ends up with as a product, deal with it. Was going to cover a handful of things today. Just going to quickly go over some of the improvements we made for 4.0 and 4.1. That includes some performance modifications, mostly things that were in 4.0. So if you're using 4.0 already, you're familiar with them. In particular, iSCSI multipathing. It's going to cover some of the additional Broadcom iSCSI HBA support that we've added for 4.1, as well as some of the DDK and third-party vendor support, including the Dell EqualLogic multipathing package that they provided. I'm going to go through a bunch of iSCSI configuration setups. I hope that you're well caffeinated, or have your 1 hour energy drink, or have had your meth, because there's going to be a bunch of them. I recommend that you download these slides from the VMworld site afterwards if there are any configuration examples that you want to look at in particular, because I'm going to fly through them. The ones I'm going to hit in particular are iSCSI multipathing. iSCSI multipathing with dependent iSCSI HBAs like the Broadcom adapter. Just a quick example of how to set up a VDS with iSCSI multipathing. Quick little tidbit on IBF boot configuration. I'm going to go over just a quick explanation of how the new vendor storage PSPs work, like the Dell EqualLogic multipathing. And I'm going to cover a bunch of best practices in troubleshooting some of the most common questions and problems that I see iSCSI customers running into, just in hopes that if you see the same thing, you know how to take care of it. Give you a couple examples of what debugging tools to use, also, just to figure out some basic information. So let me hit on the improvements first. If you have 4.0, you're probably familiar with this already. One of the biggest scalability improvements that we made in 4.0 and enhanced in 4.1 is iSCSI multipathing, the ability for the iSCSI initiators on an ESX host to have multiple storage endpoints, and therefore use those storage endpoints as storage paths. The idea is that there's still one iSCSI software initiator on the system. It still has a single iSCSI initiator name. However, you can have a bunch of different VM kernel NICs hooked up to this iSCSI initiator. Each one of them will have a separate IP address, so your storage will see separate ports connected to it. The big advantage of this is that it allows more sessions between your ESX host and your targets on your storage. One of the big advantages of this is that it allows the storage multipathing path selection policies to take care of how to make the best use of those paths, as opposed to if you're using NIC teaming with multiple NICs. The NIC teaming doesn't necessarily know how to best use the storage, so we allow the storage stack to take care of that. In addition, we have we have support for a bunch of new. We have a support for new HBAs. In particular, we have the Broadcom HBAs in the box, and we have a DDK that we've published that allows third-party vendors to actually write their own drivers and management utilities, if necessary, to work with ESX. We struggled a little bit to try to figure out how to describe the various different types of HBAs that you could have on an ESX system, and came up with the idea that basically they're independent iSCSI HBAs. This is the way that the current QLogic HBA works, if you're familiar with it at all. The HBA itself is entirely self-contained. You load up the IP information, the discovery information, all of that directly into the HBA. It does not use the ESX VM kernel networking stack at all. That means that you can pretty much set up the HBA and have it entirely separate from your VM kernel networking configuration. They don't interact in any way. The way this is handled is there's actually a management plugin that the vendor would supply, like QLogic has supplied one for their card, that ties into the VI client and vCenter to allow you to configure your system. Contrast this with a dependent iSCSI HBA. This is the model that Broadcom uses. The configuration is actually stored with the iSCSI, with the software initiator iSCSI information. The HBA actually borrows the IP configuration from ESX VM kernel networking. That includes like IP address, MAC, VLAN. It counts on ESX to actually do the discovery and authentication before handing over the offloaded session to the iSCSI HBA. As a result of this, you have a VMKNIC that's configured up to talk to your iSCSI target, but if you look at the stats for it, you won't actually see any of the iSCSI traffic going over that VMKNIC. The traffic is actually going through the iSCSI HBA. One of the things that's a little bit simpler for storage vendors that put together this type of HBA is that the management is handled entirely by the ESX management plugin that works with the software initiator as well. Therefore, hardware vendors don't need to come up with a management library. So here's a quick picture of how they differ. The dependent HBA actually talks to the iSCSI daemon in ESX that we use for our software initiator as well. And all of the configuration for this is actually stored in the configuration database on ESX. You can contrast that with the independent one that actually talks to the kernel components of our iSCSI stack, but has its own management plugin and does not interact with the iSCSI daemon at all. I do want to point out off to the side that one of the other additions for 4.1 is the ability to actually have a vendor daemon that talks to our iSCSI management library and can set up or tear down sessions or do other configuration. And this also communicates with the multipathing SCSI, the mid layer in ESX, and can trigger path selection changes. So here's where we get into how you actually configure this on your ESX host. I want to point out that configuring iSCSI multipathing is optional. If you turn on the software iSCSI initiator on your ESX host, it will just work. You don't need to do any of this configuration. If you upgrade from a pre-4.0 installation, it will work just fine. Everything will be configured properly. You don't need to make any changes if you don't want to. The iSCSI multipathing is referred to in a lot of white papers and KB articles and blogs as port binding. That was an internal name that we just came up with to describe the feature. VMware has documented this as iSCSI multipathing, but if you see the term port binding, that's talking about the same thing. The iSCSI multipathing is available with the ESX iSCSI Initiator and the Broadcom Initiator. QLogic, since it's an independent adapter and each port looks like a different storage port already, has no need to make use of this. So the iSCSI multipathing is normally only used to describe iSCSI multipathing on the software initiator or Broadcom. It uses both the UI and the command line for configuration. Unfortunately, we did not get everything into the CLI or into the UI. So once you've done a handful of the configuration through the UI, you do need to drop down into a CLI to finish up the configuration. Right now, there's actually you can do some routing with the iSCSI multipathing configuration on your ESX host, but it's difficult. I'm not going to describe how to do it. Our documentation says it isn't really there. If you absolutely have to do it, take a look at the KB articles that are out there. So in 3.5 and before, or if you set up a host without iSCSI multipathing, you would end up configuring a single VMKNIC that would be used for your iSCSI traffic. You'd have a vSwitch that has some NIC teaming policy and some handful of physical NICs associated with it. And you could end up using multiple Ethernet links through your between your host and your storage. But from the ESX side, it would appear to be a single storage endpoint. So the change for 4.0 and 4.1 is that each NIC will end up being a different storage endpoint. keep in mind that the ESX Initiator still appears to be a single vmhba, even though there are multiple ports on the host associated with it. You can set up this configuration to work with either one vSwitch or as many vSwitches as you want on your system. Do your vSwitch layout on your host however makes the best sense for whatever else you're doing on your host. The iSCSI multipathing will work with it regardless. And this is true for both legacy switches and the distributed vSwitches. The way that you actually configure this is that you set up a VMKNIC associated with a port group that has a single active uplink. That would mean that there's no standby uplinks, and any other uplinks associated with that port group on that vSwitch would be unused. So when you're doing this, you'll assign each VMKNIC a separate IP address. Once you've set up the VMKNICs, the piece that you need to do in the CLI is actually associating those VMKNICs with the iSCSI vmhba. If you don't do this, even if you configure the VMKNICs, you will not have iSCSI multipathing set up. The advantage to this is that once it is set up, as I mentioned, the path selection policy and the storage mid layer will take advantage of these as multiple endpoints and therefore multiple paths. And it works great with our prepackaged NMP multipathing with PowerPath and the Dell Equal Logic package that they've supplied for 4.1 as well. So here's an example of a picture of how it would look when you've set it up. You would create a handful of VMKNICs, each associated with an uplink or physical link on your host. You would set up a vSwitch policy that actually has a one-to-one correspondence of this VMKNIC is associated with this uplink. There's no NIC teaming between the uplinks associated with each of the VMKNICs. And the advantage of this is that when it's all set up, you'll end up with as many paths as you have ports on your ESX host times portals on your storage. So if you're running a multi-portal storage, it will end up seeing multiple storage portals and create paths, that many paths between the storage by default. So the way you set this up is go in and configure your vSwitch, create a couple port groups that have VM kernel ports associated with them, as many VM kernel ports as you have uplinks associated with the switch. Go into the port group teaming policy, edit the port properties. Here you want to check that that you have override vSwitch failover order. You want to move it. You want to configure it so there is only one active adapter associated with this port group, and all others are unused. You don't want it in a standby adapter here. This is actually described in detail in the iSCSI SAN configuration guide. There's no quick pointer to it other than right here. It's on page 32. So at this point, you have to actually jump into the CLI to finish the configuration. So the command to take a look at what NICs are associated with a vmhba is ESX CLI software iSCSI NIC list, and then you specify an adapter. We'll start off with no NICs configured. So after you saw the configuration we did the previous page of setting it up so there's only one active adapter, we can add the VMKNIC associated with the port group to the adapter, and you get the prompt back because it works successfully. At that point, if you list the NICs available, you'll see that VMKNIC 1 associated with the physical NIC VMNIC 2 is attached to vmhba 35. So at this point, let's try adding VMKNIC 0 to the adapter as well. Here you get the cryptic, no useful information error, add NIC failed in IMA. This is an indication that the operation failed. So let's take a look at the vSwitch and see what could have possibly happened that went wrong here. So in this case, We have iSCSI 2, which actually has an uplink of VMNIC 2. However, we have iSCSI 1 that actually has 2 uplinks. So when we tried to add the VMKNIC that's associated with iSCSI 1, it failed. Well, you can go back to the UI and fix this, or actually there are command line options to allow you to fix it as well. The ESX CFG vSwitch command at the command line will allow you to remove VMKNIC 2 from the port group iSCSI 1 on vSwitch 1. And you type in that command, you get no response. That means it was successful. You take a look at the vSwitch, you see that we have the proper number of uplinks on each one, and at that point, you can add VMKNIC 0 to the vmhba. You get no errors, therefore it worked properly. And if you take a look at the screen, you can see that we have 2 paths to a single portable storage device here through the software initiator, demonstrating that we actually have set it up properly. One of the ways that you can also tell this is the target number and LUN number will be the same, but the channel number will have changed. So the channel number is actually showing you the 2 different paths between the storage and the host. So for 4.1, we added the capability to do this with Broadcom iSCSI HBAs. The Broadcom iSCSI HBAs include the 5709 and 57711. Actually, Broadcom is here in the Solutions Center. You can go visit them at 1601. And Abi Aswath here is here from Broadcom. He would be happy to demonstrate for you and show you all sorts of configurations down in his booth. So I followed the software iSCSI multipathing with Broadcom so quickly because they're very similar. It's pretty much the same steps. The one primary difference is that each Broadcom port actually ends up being a different vmhba as opposed to the software initiator where all of the single initiator is one HBA and you associate multiple ports with it. There's a limitation that you can actually only associate one VMKNIC for iSCSI use per PNIC. That's not a limitation with the software initiator. However, as of 4.1, there's really no benefit to doing that. I know that for 4.0, there was some Dell EqualLogic documentation that recommended this might be a way to get additional paths to your storage. For 4.1, just set up one VMKNIC and follow Dell EqualLogic's instructions on how to use their PSP. So there are a couple limitations to iSCSI HBA. Right now, there's no jumbo frame support for it. Believe me, even without jumbo frame support, you get a huge efficiency gain from offloading the iSCSI traffic with MTUs of 1500. Right now, there's a max of 64 sessions. This is a problem if you end up with storage that actually presents each volume as a separate target, and you have a lot of different targets. Keep in mind that if you really start running into limitations, you can run your hot traffic over your iSCSI HBA and your cooler traffic over a software initiator on the same port. It all works. Keep in mind that when you actually are pushing iSCSI traffic over this, it is not recorded in the VMKNIC traffic stats. So here's the diagram of what's different between the software initiator and the Broadcom initiator. In this case, each Broadcom port is going to appear to be a separate vmhba. You have the same VMKNICs on your vSwitch. Each one of them will have a single uplink, and each one of those will be associated with the vmhba that is a physical NIC on your system. So this actually requires, you would, just like with the software initiator, you actually need to move all but one VMKNIC down to your unused adapters in your port group configuration, again, overriding the vSwitch failover order. And one of the issues that you'll run into here is that you need to actually know which VMKNIC is going to be associated with which vmhba. So there are command line options to allow you to do this. ESX CFG SCSI devs will show you a list of what Broadcom adapters are actually in your system and which vmhbas are associated with them. And then you can use the ESX CLI SW SCSI vmNIC list. This is not different from the NIC list that we saw earlier. I know they're very close. These were written internally. So in this case, you can see that the candidate VMNIC for adapter 32 is VMNIC 1. The candidate VMNIC for HBA 33 is VMNIC 2. So after you've gone in and created your one-to-one correspondence of VMKNIC with these VNICs, in this case you can see that we have a vSwitch very similar to the setup we had with the software initiator. We have a port group associated with a single uplink each. You can then use the VMKNIC list for each adapter and see which VMKNIC is the appropriate one to use with that vmhba. Once you have that information, you do a NIC add just like you did with the software initiator, and in this case we do a list. It says no NICs found. We add a NIC to that adapter, and at that point the VMKNIC is available. And once you've done this, you'll end up with again as many paths as you have targets times endports on your system. So what I just covered actually covered our legacy static vSwitch. We also support this with our distributed or VDS switch. It's the configuration or the steps you have to take are very similar to what you would do with the legacy switch. It does work with the Cisco Nexus 1000V. It also works with the ESX VDS. If any other vendors come along and supply their own VDS, they simply need to implement some of the interfaces that we've created to make sure that the iSCSI implementation works. This is particularly useful if you have blade systems or systems with limited number of ports where you want to have a VDS that applies to multiple systems. This allows you to configure VDS for those systems and have iSCSI multipathing work at the same time. Again, the limitation is that you have to have only one uplink for any VMKNIC port group associated with your switch. It's particularly important that the VMKNIC cannot move across uplinks. If it can move, it breaks the association for Broadcom NIC, and you end up with a VMKNIC that no longer is attached to the proper vmhba. Again, the idea is that any VMKNICs that are any VMKNICs that actually are associated with an unpopulated uplink will appear to be down in the system and not usable as an iSCSI link. The storage system takes care of this properly and won't actually use that as a path. So I'll mention quickly how you would set this up on a Nexus 1000V. The idea is that you actually need to add the capability iSCSI multipath to the port profile that you're using for the port group on your Cisco Nexus 1000V. Going through an actual configuration example of this would be quite long, so I'm going to simply recommend that you actually pick up the Cisco documentation. It actually describes it in fairly good detail. I will, however, mention how you set it up on an ESX VDS. It's not necessarily intuitive. You actually have to start off at your home screen in vCenter and select networking. If you're on the host page, there's no way to actually get to what you need to do. Start at the home page, go to networking. In that case, you can select the devices, select the DV port group, and at that point it becomes similar to the way you set it up for a legacy switch, where you configure it with one active uplink and all of the others are unused. So once you've done this with a new DV switch, if you go into the configuration, you'll see that there are port groups that have one active uplink, and the other port group also has one active uplink. And once this is done, you go into the command line configuration just like you would with the legacy switch. Another new feature for 4.1 is the ability to do IBFT booting with dependent iSCSI adapters for ESXi only. When 4.1 shipped, the initial support was for the Broadcom 57711 only. Since then, other Broadcom adapters, the 57709, 57712, and some Intel adapters have gone through the certification process as well. So there's a handful of hardware out there that will allow you to boot, do iSCSI IBFT boot Keep in mind that QLogic still can do its 13 boot as it always has. That feature hasn't changed. Also keep in mind that even though we do have ESX classic configurations that still have consoles, the IBFT boot does not work with that. So when you actually boot up your ESXi system with an IBFT boot, the ESXi network configuration is actually pulled in from IBFT, and you'll already have a port group and a VMKNIC that has a set IP address ready to go. So whatever's available from the BIOS and IBFT is actually stored in ESX at that point. So one of the next things I was going to cover was the Dell EqualLogic multipathing and the ability for other vendors to come along and do this type of multipathing as well. It's another PSP. It's very similar to the way PowerPath installs on your system. In addition to the path selection policy, they also include a session manager, the vendor daemon that I showed you in the diagram before, and that session manager runs on the ESX host to make sure that the number and types of sessions that are up on the host are doing the best thing for the storage. The Dell EqualLogic Path Management plugin has been certified for ESX. You can download it from their site. The main point of actually having the session manager is that it allows the ESX host to adapt to configuration changes both in the topology connected to the host and to any migration that might have happened on the EqualLogic storage itself. So here's a few quick diagrams of how this is set up. I used the same diagram as I did for Broadcom. This also works with the software initiator. You don't have to necessarily take pictures. You can download the slides as well. In this case, we have a clustered storage system out here like the Dell EqualLogic, and in this case, we've set up 3 sessions from the first port to different members of the cluster. So if we multiply that out by the number of ports that we have on the system, we end up with a total of 9 sessions here in between the 3 ports available and the 4 cluster members. This would be an example of how the sessions might be established. You notice the second member in the group actually only has 1 session associated with it. So with the session manager can take a look at this and say, well, we're down to a single link that will actually supply information to that member in the group. So why don't we actually use the session manager to move some of the sessions to it, and that will happen at the ESX host, and you, as a customer, you won't actually see any changes happening. You should actually see better throughput. So I'm not going to actually go through a full configuration example of how to set this up. It is quite simple. It's a package that's downloadable from Dell. The configuration of the host is actually part of the package. And keep in mind that the whole point of this is that it handles both sessions and path management, and the goal is better performance. So I'm going to hit a handful of iSCSI configuration best practices that VMware recommends. If possible, with your software initiator, it makes sense to set up jumbo frames. This uses a little bit less overhead on both your host and your storage, with the limitation being that you actually need a switch that handles it. Most switches will these days. Keep in mind that it has to be configured in 3 places on ESX. It needs to be configured at the VM on the switch, on the vSwitch. The vSwitch needs to have a port group specified that it has an MTU 9000. You actually need to have NICs that have MTU that are capable of handling MTUs of 9000. And then you need to configure the VMKNICs to actually have an MTU of 9000 as well. Here we have VMKNICs that have MTUs of 1500. So in this case, let's change this one to actually you have an MTU of 9000. What you do is you end up removing it first and then just re-adding it with the same configuration parameters and a -M 9000. And if you take a look here, actually it was the first one that we removed, and the configuration is exactly the same, except now it has an MTU of 9,000. You repeat this operation for the second VMK, and actually, if you're using iSCSI multipathing, you can do this while it's running and rebind and actually never lose connectivity to your iSCSI storage. You can test the MTU size using the VMK ping command. It's an internal test tool. We don't document it very well, but it is useful to actually make sure that you do have end-to-end MTU possibility. One of the biggest problems that we still run into with both internally and with customers is Ethernet congestion. We end up with rather complex configurations and end up with lots of storage trying to cover a single ISL or uplink between switches. Keep in mind that the storage is supposed to be shared, and the links that are associated with it are shared as well. Ethernet congestion won't actually cause you to lose any data or corrupt any data. It simply ends up with lots of TCP retransmissions that slow everything down. Even with flow control helps an awful lot for Ethernet congestion, but it's not perfect. You actually will end up dropping packets from time to time, and especially if you're running yourself into a congested situation, flow control will still won't actually prevent the congestion from causing problems. Lots of people say, well, I have my iSCSI traffic on a separate VLAN. Keep in mind that the VLAN is going to be shared with other physical traffic, and unless you actually have very good QoS capabilities on your network, it means that your storage traffic is still competing on the network with other traffic. So here's a quick diagram to explain what's going on. If you have a couple hosts over here that are actually trying to dump data across 1 gigabit links to a switch that's connected to the storage with 1 gigabit link, you're going to end up with drop packets. The most obvious fix for this is to configure your network appropriately so you don't end up with bottlenecks. Delayed ACK is one of the other things that tends to be misconfigured quite often. Just quick explanation of what delayed ACK is. No delayed ACK is the host sends a command to the storage acts it, host sends a command, the storage acts it. In this case, there's actually a packet that gets sent and an acknowledgement of that packet, so it happens either direction. The idea of delayed ACK is that actually you don't need to end up in this lockstep configuration of something going across and an acknowledgement happening. You can send a bunch of them, and you can piggyback the ACKs together, or you can piggyback the ACKs on a response, or you can actually just combine them together. Delayed ACK isn't supported on all storage systems. There's a handful of storage systems out there where if you enable delayed ACK, you'll actually see the sessions dropping fairly regularly. If you end up seeing things like storage degradation or session drops in your log with certain types of storage, one of the best things to try is disabling delayed ACK. That said, it should always be enabled when you can. One of the reasons that people tend to turn off delayed ACK is that they'll try doing a single file copy on a guest OS, or even worse, in the console OS, and because the lockstep nature of the command going out and the ACK having to be completed before, because there's not the lockstep of the command going out and the ACK might be delayed while the storage is waiting for potentially another TCP response to piggyback it on. Doing a single file copy, you actually can see better performance this way. It's not a very good test, and it's not a real-life test either. There are a handful of public domain utilities out there that actually do good performance testing. Iometer and Blaster are a couple of examples. And the other thing is, if you're actually running ESX Classic, the console OS is purposely choked to not have very good performance because we never wanted the console OS to get in the way of VMs running properly. So the console OS actually has a maximum queue depth of 2. so you'll never actually get a whole lot of I/O bandwidth there. Another thing that you can actually do to improve path aggregation on your storage is to use the NMP round-robin multipathing. If you turn it on from the UI, the default round-robin policy sends 1,000 IOs down each path before it switches to the next path. This, especially for 1 gigabit iSCSI storage, this is quite a few IOs, and you don't actually end up with a whole lot of aggregation. You actually end up with just a bunch of commands happening, a path switch, a bunch of commands happening, a path switch. The way to actually make better use of the aggregation is to go in and change the IOP policy. So if you take a look here from the command line, you can go in, use the NMP round-robin configuration commands. You can get the configuration, see that it starts off at 1,000, go in, change it to 1, and list it again, and you can see it changes it to 1. You might want to actually see if your storage vendor has other recommendations. Some of them will recommend a number like 3 or 5, a little bit higher number than 1. You know, if you're trying to scrounge all the aggregation you can, experiment, see what ones works best for you. Here's a quick picture of what ends up happening. If we end up with I/O count of 1,000, they actually end up very serialized across the multiple paths. This would actually should have a much smaller space between them. You actually do see an awful lot of overlap, especially with the queue depth of 32 or 64, which is what we have configured by default on our iSCSI adapters. There are a couple disadvantages to round-robin tuning. It actually does consume a few more cycles. Every path switch actually consumes some CPU cycles on your ESX host. Compared to the speed up you'll see in the throughput, the amount of CPU that's used is not that much. There are or were some storage systems out there that actually had a cache that was associated with each port on the system. So you would end up completely defeating the caching capabilities of the storage by going for a complete round-robin setup. That was actually part of the reason for the 1,000 IOPS that we do by default. If you see better performance using 1,000 IOPS rather than 1, there's a good chance your storage is doing something like this. There's a handful of parameters that you can configure on the software iSCSI Initiator through the command line as well, actually through the UI. They're listed. There's initial RDT, initial burst. If you really think that you can squeeze something out of your system, go ahead and play with these. They're tuned to a pretty good number all the time, and if you're going and playing with them, don't expect any miracles. There's none to be had. One of the things that's actually out there on some blogs and some forums right now is the idea that you can actually change the default queue depth on your QLogic card. Sounds like a great idea. Change the default queue depth to anything you want on your QLogic card. The ESX driver ignores that parameter, so it's not going to change your performance at all. I'm going to hit a couple of the iSCSI configuration pitfalls that we hear fairly regularly. One of the biggest ones is working with storage that actually won't accept multiple logins from the same IQN. So this is a case where you're trying to configure ESX software iSCSI multipathing, and you don't end up with good multipathing. One of the chunks of hardware that had problems until like last week were Clarions. Flare 30 actually came out last week and solves this problem. So before you go through and implement this, just go upgrade to Flare 30. So here's an example of what happens. You actually have a couple ports on your ESX host. The first port logs into the first port on the storage. It gets established. The second port tries to log in as well, and it fails. If you look in your logs, you'll see a message that says connection failed out of resources. So you follow this logically. The same thing happens here, where you attempt to establish a connection to your storage on the second port, and the first one succeeds, the second one fails. So you do end up with multiple paths, but not really what you want. So the way to work around this, and there are other types of storage that run into this problem, is actually put your your iSCSI ports on your host and on your storage on different subnets. So in this case, you end up with different subnets here. The first port attempts to log into the first port on the storage, and it succeeds. This one will fail. You'll get a host unreachable comment in the logs if you ever look at it. So you don't actually establish that connection. Go down to the second port. Again, the first port can't log in. The second port can. And you do end up with your multipaths. This gives you redundancy and aggregation if you want to set it up. There's a couple things that you'll run into if you start using the Broadcom, or that you could run into if you start using the Broadcom iSCSI adapters. You do actually have to license some of the Broadcom iSCSI NICs, and if they are not licensed, the biggest sign will be that you don't actually see a vmhba associated with the Broadcom NIC. In this case, it usually means it's not licensed. You can verify this by looking in the log, and you will see one of these two messages: LAM is not enabled, or iSCSI not supported, and it will give you dev. There's different ways of doing the licensing on your iSCSI NICs. On one of the OEMs actually uses a software way to set it up. Another one actually uses a card that plugs into the motherboard. It is very OEM specific. Don't talk to us. Don't talk to Broadcom about how to make it happen. Talk to whoever sold you your hardware. In most systems that are sold right now, the licensing is already there by default. You don't need to do anything special. Another thing that you might actually run into with the Broadcom is if you see incredibly poor read rates, like what's going on here, read rates, one of the things that probably is happening is that the Broadcom chip is receiving some out-of-order frames. When they get reassembled in the Broadcom chip, it actually ends up taking some time. The way to work around this is to enable flow control end-to-end on your iSCSI network, and it should clear right up. There's a handful of tools that are out that we have available in ESX and elsewhere for figuring out what's going wrong with your iSCSI configuration. Ethernet congestion, big thing. Take a look at your switch stats. So here we're looking at the port statistics for a Cisco switch, and in this case, you can see that we've received 62,000 frames, and we've dropped almost 10,000 of them. This thing was reporting 0 throughput when I captured this. We also have ways of seeing how many drops you get on through ESX Top. If you fire up ESX Top and hit capital N, it will give you network statistics. In this case, it's a clean system. I didn't actually have a screenshot that had a bad system. I need to update this slide at some point. There's session information available. This is new for 4.1, so you can go in and use the ESX CLI SW iSCSI command to get your sessions. In this case, there's only one session listed for the vmhba because it's already in iChart as it is. This would actually list all of the sessions that are available. Keep in mind that even though the command name is ESX CLI SW iSCSI, it applies to both the software initiator and any dependent iSCSI HBAs. Bad command line naming, what can I say? So here's, actually this is the exact same screen demonstrating that you can actually use this information as well to figure out what sessions you have using your Dell EqualLogic Session Manager and PSP. There's proc nodes for the QLogic driver. This will actually give you the driver and configuration name or configuration information for your QLogic card. There would be target and session information that follows this as well if there were actually any targets on this. Again, I didn't need to make it a busier screen. Same thing is true for the ESX iSCSI Initiator. The name of that driver is actually iSCSI VMK. If you take a look at the proc nodes, you can see some configuration information. Here we actually do have a session that's active, and it shows you all the configuration parameters associated with that session. Broadcom, once again, there's a handful of driver parameters that you can view here. This would potentially be useful debugging information if you're running into problems. This would also list sessions below it. Again, it would be very busy to try to show that. And at this point, that was all I had. Do we have questions? Yes. Did we up the number of limits on 10 gig ports? I'm pretty sure that the iSCSI Initiator will support 4. It might actually be up to 8. Yes, we did up it. I don't know the number off the top of my head. If you take a look at our 4.1 HCL online, it will actually tell you.
Can you repeat the question for the record?
Yes, I'm sorry. I did repeat the question. Did we up the number of sessions or number of ports that were available for 10 gig NICs on ESX? And the answer is yes, we did. Okay, thanks everyone.